talk to you about Unit 2, Lesson 1. In Lesson 1, we learned about zero and negative exponent laws. Some key things that you should remember are when multiplying powers with the same base, you add the exponent. So a to the power of b times a to the power of c, you would keep the base the same. So you would do a and then you do b plus c and get the answer. Second, when dividing powers with the same base, you subtract the exponents. So a to the power of b divided by a to the power of c, so you would do a and then you do b subtract c and get the answer. Lastly, when power is raised to another exponent, you multiply the exponent. So a to the power of b raised by c, you would do is a and then you do b times c in order to get the answer. So now we're going to do the examples for the exponent laws we have learned. So the first example is 3 to the power of 2 times 3 to the power of 3. Since this is multiplication, you would add the two exponents. So 3, so you would do 2 plus 3, and then you would get 3 to the power of 5, which is the answer. Second example is 5 to the power of 5 divided by 5 to the power of 3. Since this is subtraction, you would subtract the two exponents. So 5 subtract 3, which gives you 5 to the exponent of 2. Last example is 5 to the power of 5 raised by 2. Since this is being raised, you would multiply the two exponents. So it would be 5, and then you would do is 5 times 2, which gives you 10. So 5 to the power of 10, which will give you the answer. Something you should always know is when a base is raised to a zero exponent, the result is always 1. So for example, a to the power of 0 will give you 1, or a to the ax power of 0 will always give you 1. So basically, every exponent that is a 0 will give you 1. So basically 0 equals 1 every single time. Also, you should know when a base is raised to a negative exponent, you write the reciprocal to make it positive for a positive exponent. For example, 3 to the power of negative over 2, you would flip the negative. So you would flip. So since it's always 3, it's always 1 over 3. Since it's always 1 over 3, you would flip the 1 over 3 to 3 over 1 and make 1 over 2 positive. Another example would be 2 over 3 over 4 negative. So for this, you would flip the 1 over 2 to 2 over 1, and change the negative 3 over 4 to a positive 3 over 5. And next, another example could be 4 to the negative 1 over 3. In order to make that a positive, you would flip the 1 over 4 to 4 over 1 and make 1 over 3 positive. So now we are going to talk about Unit 2, Lesson 2, which we learn about rational exponents. Some terms that you should keep in mind are rational numbers. Rational numbers can be expressed as ratio of two integers. So for example, 3 over 2, 5 over 2, or 0.40 can all be expressed as ratio of two integers. Second term that you should also keep in mind are rational exponents, which are exponents that are in fraction form. So for example, 6 to the exponent of 1 over 2 or 3 to the exponent of 2 over 3 are all rational exponents. So some exponents are written in the form of 1 over n, where n indicates the index, and also are natural numbers. And also n can never be negative. It always has to be a positive. Also, there's another form that it can be written as in, which is m over n, which both of them are positive numbers. So some examples would be 16 over 1 over 2 which 16 over 1 over 2, which to change this to a radical form, you would do is, as a denominator, you would keep it at the front. Denominator always goes to the front, and then you would do that radical sign and put the 16 in as it is, and then the 1 can either go inside, beside the 16 as an exponent, or outside as an exponent. It doesn't really matter however you do it. So as for now, we'll put it at the 1, like that. And when you evaluate it, you will get 64. You will get 64. Sometimes you can remember, so if you want an easier way to remember this is as a flower power. Flower power where M is the growth, and the N is the root, and then the dividing line is all called the dividing line. So that's a very easy way to remember. Also, so let's do some examples. So an example, so it could be 8 to the power of 2 over 3. So if we're told to change the exponents to radical form and evaluate, this is how we would do it. So we would change, the denominator would go at the front, the 8 would remain the same, and the 2 can either go beside the 8 as an exponent or outside of it. So you could either write it as 2 like that, or you could write it as 2 right here. But it doesn't matter. Either way, you would get the same answer. So when you evaluate that and you plug it in the calculator, you get the answer as 4. Another example we can do is 16. So you could do a 16. We could do a 16 to the power of 3 over 2. So when you change this into a radical form, you would put the denominator at the front, and then 16 as it is in the middle, and either 3 could go here beside the 16 as a exponent or outside as an exponent. Either way, you could do it this way or this way. Doesn't matter. And when you evaluate that, you get 64, which will give you which is the answer.